389. The laws of logarithms. First law is the product law. The product law is related to the product of exponents, right? What's the law when you multiply exponents or powers? You add the bases, right? Not add the bases, add the exponents, okay? Which is, it's really interesting because if you would go to a grade 9 class, sometimes a grade 9 class, they're so deeply involved in exponents that you actually hear teachers take away words, which would totally screw up elementary kids. The words they take away, they say, okay guys, remember the rule, what do we do when we multiply? And then the whole class responds, you add. And an elementary kid would be like, what the heck's wrong with you guys? Multiplying and adding aren't the same thing. We've taken out words. What's the rule? When you multiply powers with the same base, you add the exponents. But it seems like it's too much to say all the time. So you start hearing teachers and kids take away words and say, oh yeah, what's the rule for when you multiply? Oh, you add. Right? The elementary kid be like, high school kids have lost it. A little bit later, what's the rule for dividing? No, right? We take out the words, but you know what we're talking about, right? With powers, you can add and subtract. Okay? Now, in logarithms, something similar happens. In a logarithm, if you are multiplying inside a logarithm, you can just decide to add the two logs together. And vice versa, if you're adding two logs together and the bases are the same, you can multiply inside. If we go back to the one that I was trying to mess you up on, check it out. I'm adding together two logs with the same base. This would be the same as multiplying that together. What is 4 times 16? 64. And now can you see that the answer needs to be 2? Because 8 to what exponent would be 64? It would be 2. So I was using one of my log laws and pretending I could do all the decimals in my head. So that is our product law. If you are multiplying inside of a logarithm, it's the same as adding the two logarithms. And notice it connects to multiplying with powers, you add the exponent. But now you're multiplying inside a log is the same as adding. Log law number 2, quotient law. Well, what's our quotient law? Well, if you had powers, your quotient law says when you're dividing two powers with the same base, you can subtract the exponents. In logarithms, this ends up being, if you're dividing inside of a logarithm, you can subtract the two as two separate logs. Notice that the base stays the same. So vice versa, sometimes we're going to take the right-hand side and say, hey, if I'm subtracting two logarithms with the same base, I could combine them to a single logarithm by dividing. And then we have a power to a power law in exponents. What did we do here? We multiply. How does this show up in logarithms? If you have an exponent or a power inside the logarithm, you can take that power and pull it out in front and multiply by it instead. Which is kind of crazy. So these are our 3 main log laws. Or do they have a proof? Yeah, you can look at the bottom of the page, they prove one of them. How you can use your laws from exponents to prove your other laws. We won't worry about that. These are on your formula sheet. You just have to be really, really good at using them. So we'll go to example 1. And we are going to further define what the English word simplify means. Okay? Up till now in grade 12, you have learned that simplify is a very important math word. The math teacher always telling you, oh, you need to simplify your answer. Okay? If we would make a list of all the different places math teachers have used the word simplify till now, there'd probably be about 20 different things that it means. Like sometimes it means just put your numbers together. Right? 2 plus 3, simplify. Oh, it's 5. Right? Sometimes it means combine your like terms. Like 2x plus 3x, that's 5x. Sometimes it means your fraction has to be in lowest terms. Like if you write it as 2/10, it's not simplified, it has to be 1/5. So we have all these things for simplifying. Square roots, you can't leave an answer as the square root of 8. It's not simplified. What do you have to do there? 2 root 2, right? You also learned you can't have a square root on the bottom of a fraction. You have to rationalize the denominator. So 1 over the square root of 3 is not simplified, but square root of 3 over 3 is. So it is my opinion, in mathematics, the most complicated math word there is simplify. And now, oh, we have logarithms. Let's just expand the word simplify. In logarithms, we call something simplified if it's a single logarithm. So in each of the formulas, and I have the 3 formulas plus one more on the board over here, the right-hand side is considered the expanded side, and the left-hand side is the single logarithm, is the simplified side. So for the very first one, this isn't considered simplified because we're adding 2 logarithms. But I have a log law that says if you add, you can multiply inside, which would make this log of 56, and that would be considered simplified, a single logarithm. Log 5 of 2 in B, I can take this 5 and move it inside as an exponent. Now it's a single logarithm. Before it was 5 logarithms. Because there's a 5 in front. 5 times this makes it 5 logarithms. I want a single logarithm, and I can simplify that to be log of 32. And in C, subtracting, there's a log law that says if you subtract and your bases are the same, you can combine it as a single logarithm by dividing, and 80 divided by 16 is 5. Simplify means write as a single logarithm. Sometimes they'll say simplify, sometimes they'll actually say, can you write it as a single logarithm? So circle 4 and 12.